Hey, how you doing? Nancy Baker here. I am going to show you today the Toxprints functionality in Abstract Sifter. This is both version 8 and 9. Um, I'm going to demo here in version 9 though. There are a couple of different things here. So Toxprints simply is a set of chemical descriptors. They are structural descriptors and they are useful for toxicity and for other things as well. You can learn more about them by going here to the US EPA Cheminformatics modules and running through some of the exercises there where you can look up a chemical and find the Toxprints, which we'll do in 1 second. I have deleted everything that was here before. I've been playing around, so if you want to, you can delete everything from H onward. Be sure to select rows like that and then say delete, and 6 downward. If you do mess up your Toxprint sheet, go ahead and download another Abstract Sifter from the internet. So you start with the Toxprints functionality by getting some chemicals, and I just happened to do a query and a mesh mine, chemical mesh mine. So I have a list of chemicals here, and I'm going to use these chemicals. The query I ran was xerostomia chemically induced, so a lot of these chemicals have articles about them describing how they cause xerostomia or possibly how they treat xerostomia caused by other chemicals, but we're not going to care about that right now. We're just going to get a list of chemicals. Copy the names, and you may have a list of your own. I'm just showing you a simple example of how to go from names of chemicals to Toxprints. So I'm going to paste them here, and then I'm going to go get their DTS XIDs. That's their identifiers. It's this button here. This particular ribbon is the EPA custom ribbon, which I may rename to AS for Abstract Sifter Custom. I'm not sure yet. All right, so all of these chemicals have DTS XIDs. Now I want to go get the smiles for them. The input to the Toxprints API functionality is a smile string. And so didn't find this one. I'm going to go ahead and delete that for now. I could probably go retrieve smile somewhere else, but all right, so now I have the input I need to go and get the Toxprints for these chemicals. There's a button to do that, but I need to select the chemicals I want to get the Toxprints for. I'm just going to click on this button, get Toxprints. And I was really just selecting rows. I could have selected the names. It doesn't matter. All right. Now, the first thing to notice about Toxprints is that there are many, many of them. I think there's over 729 of them. You can kind of read the names here of what they are. Again, I encourage you to go read about Toxprints. You can find links on my website or at this EPA website. If you're interested in looking what a Toxprint physically looks like, you can double click on it. Now that wasn't a good example. Hold on. Double click on the name and it'll give you the diagram. The other thing you can do is take the smiles and go to this Toxprints website, do a search, put the smiles in. You can also put the DTS XID in. Say run, and it will retrieve the Toxprints for you here. I would like to compare what's here to what is here, but there are so many columns that I can't see with any sort of coherence what kind of Toxprints this chemical has. So let me show you how to sort these columns so you can bring all of the Toxprints that this drug has over to the left where you can see it. So I'm going to sort on the selected chemical, which is amitriptyline, and now I can see all the Toxprints with the one here, 0, meaning it doesn't have the Toxprint. Here they are. So 94, there were like 8 of them, 94 to 586, 94 to 586, 8 Toxprints. Okay, that makes me feel good. And what this has done, it's sorted the columns, and so you can see too the similarity this particular chemical has with some of these other chemicals. But this is it's not a calculation of similarity, it's just a visual sort of similarity. So a lot of stuff over here, so we really need to calculate all the zeros and ones to find similarity. Let me show you how to do that. So let me go ahead and pick another chemical, clonidine here. I'm going to select that, and I'm going to sort the columns by that chemical. The Abstract Sifter puts clonidine in row 6, sorts the columns so you can see everything, all the Toxprints that it has. Now I'm going to do a similarity calculation to clonidine. And I can see here that 0.21 is this chemical with the closest similarity, and that is not very similar at all. Let me just try a different one that might have more similarity. This is just, I'm playing around here. So amitriptyline, now I want to get the tanning motor distance. Okay, here's some with a lot better similarity. Amitriptyline, doxapent, imipramine, etc. So that's, that's kind of interesting. And if you want to actually visualize the structural similarity, or actually see a picture of the diagrams, of course you can use that other feature. Let's take the first 5 here. Start to break down in similarity and do the tiles functionality and take the default on all of those. And on the tile sheet, you see the structural diagram of all those chemicals. And you can see that they are pretty similar here. They all have this particular structure. Okay, now we feel better about our data. And the next steps I'm going to show you, but not in this video, are how to do some soft prediction, is what I call it, where you actually look at the structural entities and see how they relate to a particular activity. That's in the next video. Probably should show you 2 other things in this one though, and that is sort by Toxprint count. So this will sort on this row, shows you the Toxprints that are in the most chemicals here, and no surprise, that's the most common one. The other thing that you can do by the number, there we go. So that's not very helpful. It just sorts by the number of the Toxprint because they each have an identifying number. Okay, so that is all for this particular video. Look for another video that shows you how to do what I call soft prediction using Toxprints. Goodbye.